Okay, so in this video, we're going to walk through the steps of using Octave to fit a linear regression, minimizing the least squares. So first off, we need to open Octave. Oops. Good if I spelled it right. And since the data I'm using is large, I need to import it. So I'm going to change my directory so I can find it. So first to present working directory, so pwd, see where I am, and now I'm going to change my directory. So change directory, I know it's OneDrive, where is it, education, colon, 2318. And if anytime you need to figure out what's in there, you can always use double tap the tab button, and it'll show you what's presently available. I'm in linear algebra, so I want notes, week 2, what else is in there? Whoops, and I forgot to end it with a parentheses. All right, so now I can see my present working directory, and I can use ls to list what's in there, and the file I want to open up, I want to load up, is called linear data examples.csv. So I will import that in. So I'm going to call it data equals, since it's a CSV file, I'll use CSV read, and then linear data example.csv. And I'm going to put a semicolon at the end because I don't want it to print everything to the screen. So let's see how big that data is. So size of data. So we see I have 100 rows and 2 columns. Let's take a quick look to see what's in there, 1 through 5. And then we'll, so I'm just going to look at rows 1 through 5. And so you can see the input is the first column. The output is the second column. And I'm going to go ahead and separate that out. So I'll call it input is equal to data semicolon, because I want all the rows, and then the first column. And y will be, again, all the rows and the second column. Okay, now I'm wanting to use linear regression to fit this, so the very first thing I should do is just check the data to see that it linear fit's going to be good if it has kind of a linear structure to it. So let's plot, and we'll plot the input for the x values, y for the y values, and I'll use little dots to print it. And we see here that here's our plot. And since I'm going to want to check my linear fit, I'm going to go ahead and hold that so that it stays in place. Okay, so we know that in linear fit, as we saw in the lecture, the x value has to be a first column of ones and then our input value. So to set that up, I'll let x equal, I'm going to use the ones function, ones. How many rows? Well, it should be the same number of rows as the input. So I'll use a comma 1 there to say I just want to know how many rows. If I put a 2 there, that would tell me how many columns. And so the ones will be that many rows of just 1 column. Right? And then input as the second column. And again, we'll put a parentheses, or sorry, a semicolon, because I don't want that to print the page. Again, let's check to make sure the formatting got done correctly, and sure enough, there we go. Ones in the first column, and then here's our x values, which is exactly what we saw from the data, 1, 2, 3, 4, 5. Okay, so then very simple, straightforward. A is going to be the inverse of the transpose of x times the transpose of x times my desired output. And there we go. This will be my y-intercept, 26.9351, and here's the slope, 1.9743. So let's make sure that that's really a good fit. So I'm going to go ahead and plot. It'd be x times a, and I'll color it red so that it will pop. And let's take a look. And there we go. There's our linear fit right through the data. And there's the data. We can see, sure enough, that seems to be a good fit.